All right, did you get them? Good. Very good, Susie. Okay, now, I'm gonna start reading them off. You kids can read right at home. Oh, it's like romper room. You kids read at home with Miss Susie. Number one, Betty is sitting at a stoplight. Okay, the light turns green. Betty gets up off her butt. I mean, I literally, when I wrote this, I made it that she was sitting at the stoplight. Okay, she gets up and she steadily increases her velocity until she reaches 30 meters per second after 3 seconds. Betty can run. Okay, you don't mess with her. She can run. So, yes, and one other thing that's really important, I forgot to mention in this last video, is how fast, Betty's going to end up going 30 meters per second. How fast is that? If I told you I was driving at 30 miles per hour down 93, some of you are going to go, is it like a blinding snowstorm? Okay, otherwise, you better speed up there, buddy, because you're going to really PO some people. And that's also, you get a ticket for that, going too slow. So you know 30 miles per hour, but you don't know 30 meters per second now, do you? How are we going to get 30 meters per second? All right, well, a real general way of getting meters per second into miles per hour without going to the board and doing calculations is double it. You double it. Now, technically, I would say double it and add a little bit. Very scientific, by the way. Double it and add a little bit. So 30 miles per hour, 30 meters per second is about 65 miles per hour. Now, the doubling it would be 60, but you add a little bit. And the faster it goes, the more you add. I know it's not very technical, but it does give you a quick idea of how fast something is moving. If something is moving at 10 meters per second, it'd be about 22 miles per hour. So 10, double it, 20, add a little bit, 22 miles per hour. All right, 20 meters per second, 43 miles per hour. Double it, add a little bit. I mean, if it really just bothers you with that add a little bit part, just double it. And for the velocities we're going to be using, we're not going to be talking about 500 meters per second quite often, but you just double it. You'll be close enough for government work. Okay, that's what I always say. Close enough for government work. Okay, so dive into this first one. Oh, Betty. Go back to Betty. Here we are, Betty. Betty's sitting at the stoplight. Now, these are word problems. Some people have trouble with word problems. Some you don't. I've never met you. I won't, unfortunately. After like the first couple of weeks, I get a pretty good idea of which of my students can have a great grasp on algebra and which don't. And that's fine if you don't. And some have good understanding of how to do a word problem, and some don't. So I'm going to assume that you don't have a good understanding of how to do a word problem. So what you should do is write down what I call the physics 5. Okay? Physics 5. Physics 5. Okay, physics 5. When it comes to kinematics, there are 5 things that we can measure. We can measure initial velocity, final velocity, distance, time, acceleration. Physics 5. Write them down, see what you have. You need 3 to do any of these equations. You have to have 3 knowns to solve a kinematics problem using the big 3. Remember, big 3 need 3. 3, 3. Betty is sitting at a stoplight. What's her initial velocity? 0. She's sitting. So the initial velocity was given immediately in that problem, 0 meters per second. Okay, the light turns green. Nothing there for a variable, just a green light. Calm down, people, calm down. Betty gets up off her butt and increases her velocity until she reaches 30 meters per second. You see meters per second, that's a velocity. So we have a velocity, a new one, after she accelerates, a final velocity of 30. Sweet. After 3 segunda grande seconds time. I now have 3 variables. One of these equations will do the job that I need it to do. What do I need it to do? A, what is Betty's rate of acceleration? You can see I've labeled these problems, level 1, level 2, level 3 are the harder ones. These are relative. Level 1 is pretty straightforward. It's a pretty easy problem. If you are having problems with level 1 problem solving them, keep practicing, get to those Zoom sessions, extra help at the end of those Zoom sessions so you can have some practice with me if you need it. But this is a straightforward problem, straightforward algebra problem. Okay, let me show you how. I know some of you are going to say not so straightforward for me, okay? It's all right, we're practicing. 1, 2, 3 things I know. So what we could do is we have to go over to the big 3. and we select the equation that works. This is about selecting which equation works and then doing the algebra to get the answer. So it wants me to find acceleration. Do these have acceleration in them? You have it, you have it, and you have it. They all have acceleration, so maybe they'll all work, or maybe not. Let's go from the top. This is actually the easiest equation to use. No squares, no square roots. Okay, just straightforward stuff. Will this work? Okay, do I have a final velocity? Yes. Do I have initial velocity? Yes. Do I have a time period? Yes, and I'm trying to find acceleration. Bam! That one will do the job, and that's the easiest one to use. Sometimes you can use two equations to solve for the same unknown variable, and you pick which one you think is an easier equation. But in this case, that's the only one that will work, because I don't have any distances, and these have distances. And that would give me two unknowns, and so those won't work. That one's going to work. All right, let's do the math. Let's plug this stuff in. Final velocity, that's 30. So I'll do the math down here. 30 meters per second. Now I'm going to write out my units the first time I do this to show you how the units work. I'm not going to write down units every single time. I probably should, but I'm not going to save time and marker okay, because these things are expensive. It takes 2 paychecks to equal one of these. All right, so 30 meters per second equals 0. The initial velocity is 0 meters per second. Okay, plus acceleration. That's what I'm trying to find, so I don't know that. Times the time, which is 3 seconds. 3 seconds, okay. Do the math. Isolate your unknown variable, isolate that A. So I'm going to subtract 0 from both sides. 0 minus 0. Okay, anybody have a calculator? Crank that out for me. Ian, what'd you get? You get 0? Okay. What about 30 minus 0? Let's subtract 0 from both sides. Remember in algebra, Ian, that you have to do to one side what you do to the other. Okay? Algebra review. Some of you need it, some of you don't. Great, okay. 30 minus 0, Ian? 30? Okay. All right, so essentially then what happens is this just goes away. Boom. And that's what we're left with. Now, some of you might see it and go, all right, just divide, we're done. That is correct. So in order to get A by itself, isolate A, divide both sides by 3. Okay, divide both sides by 3 seconds, I mean, technically. And I divide this side by 3 seconds. And 3 divided by 3 goes away. So I'm left with the A over here. And 30 divided by 3 is 10, and the seconds will cancel. They do cancel out. If you multiply by the reciprocal, right here, multiply by that reciprocal. Oh, sorry, no, they don't cancel out. Drugs. All those drugs I never did. And I should. No, don't do drugs. I'm kidding. Like, all those drugs I never did. Just saying that, okay? Don't do drugs. Do physics. Remember earlier? Don't do drugs. Boy, man, physics. So, but my reciprocal, we have an acceleration. So these seconds don't cancel out. They don't. So my units are going to be 10 meters per second squared. They don't cancel. Multiply by the reciprocal. Both seconds are on the bottom. You get seconds squared. And you should have units meters per second squared if it's an acceleration. Those are units for acceleration. Okay, that's the answer for 1A. I know this is going to take a little time to go through the first ones. We'll pick up the speed, but we got to get through the algebra because some of you have trouble with algebra. That's okay. And that's all right. It's the way it is, but we can get through it. All right, now B. How far has Betty traveled during this time? So this is the same question, but part B. So how far has Betty traveled? Now that's a distance during this time, meaning the time of 3 seconds. I erased those. I should put those back up. This is 3. This was 30. This was 0. Okay, so how far? The question mark goes here. How far? And we know the acceleration rate, too. We just figured that out. So now we have another variable. Nice. This is 10, and that was meters per second squared. So I have 1, 2, 3, 4 variables, and to solve one. That means I could probably use a couple of equations. I have 4 variables I can use. Take your pick which equations you want to use. Solve for distance. Okay. Will this one do it? No. Well, that one won't work because it doesn't have a distance in it. This one? This will do it, and it's set up for distance. I would choose this one. You can use this one. You could. You could solve for D. You have A. Got that 10. Have initial velocity? 0. And we have the final velocity, 30. But it's not set up for D, and you got to do a little bit more algebra. It doesn't matter. You can still do it that way, but I'm going to use this one because it's set up for me, ready to go. Plug in D. I'm trying to find that. So it's my unknown. VI, the initial velocity is 0. And that happens a lot. Initial velocities are 0. And that whole thing here just drops out. VIT is gone. Gone. So we go, no, I don't need to put anything in for that. That's 0 times time. 0 times 3 is 0. All right, so 1/2 A, which we just calculated, which is 10. And the time is 3. And don't forget, we got to square that. So our distance we travel is going to be, okay, that's 9 times 10 is 90, times 1/2 is 45. Or you can do it this way, 1/2 is 5 times 9 is 45. 9 times 5 is 45. Come on, people, you know your multiplication tables. Mrs. Weimar is looking down from up there, making sure you're doing your multiplication. Mrs. Weimar, she was my 3rd grade math teacher, okay? She walked around and made sure you knew multiplication tables. And if you didn't know them, she would just walk up and down that aisle and she'd turn to you and point, 9 times 5. And boy, you just better spit out quickly, 45. Or you would get the look, at sometimes even a little crack on the head. Oh yeah, back in my day, you could do that. It's great. Where was I? Making like an ancient city and babbling on. 45. Now the distance. Unit should be meter. I didn't put all the units here. All right, do a unit analysis. Check it out. See if it does not come out to be meters. It should. So this is 45 meters. Actually, I'll do a quick unit analysis for you. I won't do this every time. I'll do one more for you. This boy here was acceleration. That's meters per second squared. This here was time, and we're squaring it. So that's going to be seconds squared. Boom, boom. Cancel out, left with meters. 45 meters. So if you have a distance, we've got to be in meters. Okay, that's the answer for that one. Okay, so problem number 1, solved. All right, let's do problem 2. Wilma Wilma fires her handheld rocket-propelled grenade. Ooh, Wilma, you a terrorist or what? Now, let's see. The acceleration of the rocket is 60 meters per second squared. So at the end of 1 second, it'll be going 60 meters per second. At the end of 2 seconds, it'll be going 120 meters per second. At the end of 3 seconds, it'll be moving 180 meters per second. Okay, that's what that means. A, how fast is the rocket going after 6 seconds? So how fast, that would be a final velocity. That's what I'm trying to find. The unknown is how fast, final velocity. You know, it starts at what? Rocket propelled grenade starts at 0. It's not moving until you pull the trigger. We want to know how fast it's going at the end of 6 seconds. The acceleration rate was given to me as 60. And if the units are meters per second squared, that's an acceleration. That's how you know. And besides the fact it did say the acceleration of the rocket. So, let's see, what do we want to find? Final velocity. This one's set up for final velocity right here. Let's see if this works. It's the easiest one. It's already set up for us. This one is 2, but a square root thing down here. Initial velocity is 0. Acceleration rate is 60. That'll work because we have the time is 6, so that will work. So the final velocity, you'll do the math here, is equal to initial velocity is 0. So that just goes away. Plus acceleration, which is 60. Times time, which is 6. 60 times 6, 6 times 6. Mrs. Weimar, she's looking. Very good, 36. If I add a 0, so 360, and it's a velocity meters per second. Have the right unit on there. Have your unit on there. Don't lose a point on a problem because you don't put your right unit. So put the unit down. That's my answer. Okay, 360 meters per second. Now double that, and you have to add a little bit more, but that'd be 720, about 750 miles an hour. All right, 750 miles an hour. It's pretty quick. That is right around the speed of sound. So after 3 seconds, this little bugger is moving speed of sound. Okay, was there a part B? Yes. How far has the rocket gone after that 6 seconds? Of course, I just erased everything. I do that all the time. So what did we have? Initial velocity 0, final velocity we now know is 360. We just calculated that. Distance we're trying to find, time is 6 seconds, acceleration was 60. Okay. My Physics 5, I only have one thing to solve for. This is the one I would use because it's set up for that. Now again, you could use this and solve for D. using this one. So D, VI, 0. That happens a lot of times 0. Not always, though. Gotta be careful, not always. So that's 0. 0 plus 1/2 A, which is 60. A is 60 times T, which is 6 squared. All right. T squared, acceleration, 1/2, that's 36. So 36 times 30, 36 times 30, 36, 72, 82, 92, 102, 108, plus 0. Okay, so that'll be 1,080 meters. All right, but check me. Check me. Make like hockey player and, geez, easy there. And check me. Now, don't trust me. I'm wearing this shirt. You trust the guy wearing this shirt? No. All right, check that math out and see if that's right. Okay. All right, I think that's it for that problem. And in fact, we're going to stop this video because we now go into problem 3, 4, and 5, which have to do with things going in this direction, not this direction. All right, we'll be back with that shortly.